Hello and welcome back to this series of videos on the analysis of kinetic data. In the previous video we established that the maximum decrease in absorbance happens at around about 350 nanometers. As you can see, the axis value given here, and the largest increase in absorbance happens at around about 400 nanometers. Again, you can read that from this graph by looking at the x value for this data point. So what that means is that in order to get kinetic traces out of these data, we want to plot the absorbance at 350 nanometers as a function of time, and we want to plot the absorbance at 400 nanometers as a function of time. So what I'm going to do is I'm going to show to you how you can get those data in a convenient format so that you can plot those time traces. So what I'm going to do is, again, to make all of this traceable, I'm going to save a new version of this file. It's version 3 by now. And I am now going to extract my kinetic traces. Now what I'm going to do in a minute is I'm going to add an additional tab to this Excel spreadsheet. But before I do that, I'm going to give this tab a more meaningful name. I do that by double-clicking on that name, and I'm going to just call this spectra. Now click on the plus, double-click on the name, and I'm going to say that these are my kinetic traces. So what I now want is I want my time data, and I want my absorbance at 400 nanometers, and I want the absorbance at 350 nanometers. So how am I going to get those data? Because of course here I want those data in columns, whereas on the previous spreadsheet those data are in rows. Now what you need to do is you do it simply like this. You select the time points, or the calculated timings over here. I press Ctrl C. I go to my tab with the kinetic traces. This is where I want my times. I go to paste, paste special, and I'm now going to click values, because what I don't want to happen is the time points on the previous sheet, as you've seen in one of the earlier videos, they are calculated time points. I don't want these time points to be recalculated. I simply want to take the values that I determined over there. So I'm going to select values, and the key thing, the key code word here is I want this, when I paste this, to be transposed. And what transpose does, as you see here, it turns a row into a column. So these time points are now my x-axis data in the graph that I am going to construct later on. Now I need to do exactly the same for my absorbance data, of course. So I find the data at 400 nanometers. That's over here. I select the data, Control copy, as always. Go to kinetic traces, and once more I do paste special. And now I can choose. I can either do all or I can do values. It doesn't really matter, because they are values. They're the values that we have read, that we imported from the text files earlier on. But I can either do values or I can do all. I'll do all now because these are values that don't result from a translation, from a calculation. And what I'm going to do now is I'm going to do transpose again, and there are my data at 400 nanometers. I find the data, similarly, I find the data at 350 nanometers. And again, I select them. I select the row that contains my data. I go to kinetic traces, and I go to paste, paste special, all or values as before. It doesn't really matter. I choose transpose, and that gives me all of my data now in my Excel file. At this point, I'm quite happy to see that my file is being saved, because that's exactly what I want to happen. So now that I have my data points, so my absorbances at 400 nanometers and at 350 nanometers as a function of time, I take those data, I copy them, and I go back to my origin project file. So what I'm doing in this origin project file is I'm keeping everything together, my overlay spectra, my different spectra, and I'm now going to have my kinetic traces as well. And the reason that I put all of these into the same file is because then I can trace all of my data back to the origin if I ever need to go back to these data, and that may well be for writing a manuscript, and you never know when that is going to happen exactly, so you may actually need, well, you probably want to have all of your data in a traceable format at that moment in time. So to add my kinetic data, as always, I go to File, New, and then to New Workbook. Select that. I just want a normal blank workbook, and I paste my data into that file. And if I want, I will now give a long name. This is my time. I know this is my absorbance at 400 nanometers, and this is my absorbance at 350 nanometers. And what I now want to do is I want to plot these data, possibly as a line. And what you see now is that I get a first kinetic trace, where I can see the absorbance at 350 nanometers is decreasing and the absorbance at 400 nanometers is increasing. Now this is a representation of those data as a line, but actually I'm going to delete this graph because I am probably going to prefer to have this as a scatter plot. And the reason that I'm going to have this plot this as a scatter plot is because in the next video I am going to fit a line to these data. I'm going to fit a kinetic rate law to these data. But this is what I needed. I am just going to make these a little bit clearer. Time is of course in seconds, and my absorbance is at either 400 nanometers or at 350 nanometers, and I'm going to show that by making this subscripts, so slightly nicer axis over here. I probably also want to change my x-axis a little bit. I don't need this to start at -20. I'm probably going to start it at just 0. It goes up to 180 seconds. I find that there are too many increments on this graph, so I'm going to make it go up in 30 seconds increments. That just makes it look a little bit nicer. You now see that these data points are cut in half because they're sitting at exactly 0. So most of the time it is slightly nicer to show those data points by making the graph start at, let's say, -5. As always, I would prefer, I'll leave it for now, but normally I take this legend out of the graph and I actually describe the data points and the shapes that they are in the legend. So if you want to change those, you can simply double click the little one over here. I am now going to, because I put all of these in at the same time, oh sorry, I'm going to ungroup them so that I can deal with them separately. I'm going to then say that maybe I want these ones to be blue triangles, nice dark blue, and I press OK, and there you go. We now actually have these as blue triangles and these as red filled dots. Okay, that's what I wanted at this particular point. So this is my kinetic trace, and in a next video we're going to see how we can analyze these traces in terms of kinetic rate constants. As always, thank you for watching, and I hope you found this video useful. Thank you, and goodbye.